Well, good morning. Welcome to November 17 and our economics webinar for the day, for this month, actually. Thank you for joining us. We hope that you're going to find this interesting, hopefully, if nothing else, entertaining. I've done this kind of analysis a couple different times here in the last few years. It's kind of fun to go through this. There's a little bit of statistics in here. I got to justify you getting your CEUs and making you have to sit through something that's maybe a little bit painful, a little bit uncomfortable, but we'll do it in such a fashion that hopefully it's easily digestible, and it's something that will maybe even something you can utilize in your day-to-day life. For those of you who are seeking your CEUs, I will be flashing the QR code at the end of this presentation. I'll leave that up there for at least a couple of minutes, give you an opportunity to capture that image so you can make sure you're getting your CCA credits for attending this particular webinar. For those of you who are listening to the recording, we obviously won't have the QR code available for you, but we will have a quiz that will be available on the eKonomics website that you'll be able to take to make sure that you get your CEUs for attending the session. So welcome again, and what we're going to be discussing today is corn and soybean yield trends, and then doing a little bit of a deep dive just into what we've seen over the last couple of years. You go back to 2012, which sadly I suspect we all remember. That was a pretty tough year across a lot of the Midwest. There were a couple of areas that made out better than the rest, but some of us had yield levels were well below what our typical yield levels would be expected to ultimately be. Obviously, 2012 was a pretty significant drought across a lot of the Midwest, but what's transpired since then has been pretty impressive. The yields that we've been able to achieve, the levels of production that we've been able to hit, the number of acres of production that we've brought into corn and soybean, and the yields that those acres have been achieving is pretty astounding. And we're going to spend a little bit of time talking about that today. Let me make sure I'm on my presentation. So we're going to be talking about corn and soybean yield trends. That's primarily going to be the bulk of our conversation. I will try to attribute what I think some of the trends, what's driving what we're observing from the agronomic perspective. Why do we see these kinds of yield levels? How are we achieving these types of yields on some of these, at least historically, fields that weren't in corn, soybeans? And I'm primarily talking about the Western Corn Belt, and even beyond the North Central Plains, areas where we traditionally haven't grown these crops, at least to any great extent. And then the number of acres that they're growing now and the yields that they're able to achieve are pretty impressive. And then, as is often the case when we do these high-level conversations, we want to talk about the implications for management. Now, again, I'm sitting in Ohio today. I suspect I'm talking to individuals that are representing a lot of the Midwest, maybe even some folks out west beyond what we consider the traditional Corn Belt. I just want to give you some feelers or some ideas for how do we use this information? What does it ultimately mean for you as a manager? How do you do your job better as an agronomist, right? That's when we attend sessions like this, and I've attended, to be honest, these are some of my favorite types of sessions to attend. And I'm not just speaking about the ones that I'm presenting. I generally don't like having to present. It's a lot of work. But when just observing what's going on, regardless of what it is, what are the trends, how are things moving, and then how do I ultimately take that information and translate it into something useful for me, either in the execution of my job, maybe the execution of something that I'm involved with as far as a hobby. I really enjoy these kinds of sessions. So I hope you share that today. The other thing I do want to share is at any point during the proceedings, feel free to answer questions. Those will all be private and anonymous. The only ones that will see the questions are myself and the moderator. Please feel free to throw those up there. I will be paying attention and scanning back and forth and seeing if there are any questions that are posted. As those questions come across, I will do my best to answer them. And I will try to leave a little bit of time at the end of this hour to have a little bit more of a conversation if there are any questions. If my track record is any indication, I'm probably going to finish and wrap up right around 11:45, 11:50, maybe even a little bit later, just depending upon how long-winded I am today. But I do want to leave some time or give you the opportunity to ask the questions that may be at the top of your mind. I would prefer them to be on topic, but they don't They don't necessarily have to be. Avoid anything of a personal nature. But if it relates to agriculture, soil fertility, in my world, everything is fair game all the time. So let's get started talking about corn and soybean trends. And here's where I have to justify a little bit of your time in collecting that CEU for your CCA credits. A little bit of a statistics intro. I'm not going to spend a whole lot of time on this. If you've had a linear regression class as an undergraduate, or maybe even as a graduate student, this is going to be a refresher course. We're obviously not going to be doing a deep dive into this. We're not going to dive really deep into the math. But since this is what I'm going to be speaking to today, I just want you to have a general understanding of some of the terminology that I use and what the type of analysis that I'm ultimately doing. So when we talk about the world of linear regression, we're talking about identifying or observing a relationship between two different variables. Now there's multiple types of regression. We're not gonna get into multi-factor regression. We're not going to make this this is all going to be linear. We're not going to be talking about polynomial models. We're not going to be talking about exponential models. Everything that we're dealing with today is going to be fairly simplistic and straightforward. We're only dealing with linear regression models. So we can identify how well these two factors, now these are just two factors that I made up, this is completely fabricated, how well these two factors are ultimately related to each other. The one thing I do want to mention about conducting regression analysis or correlation work is just because two things are correlated doesn't necessarily mean there's a causal relationship. Just because this x-axis and this y-axis have a pretty strong relationship doesn't mean that, you know what, this is ultimately what's controlling y. This is what's ultimately dictating. It just means there's a relationship between these two, that as I increase this value, as I observe an increase in this value, I observe a corresponding increase in this. It doesn't necessarily mean that this is causing this. It just means that they're related. They could be responding to an unmeasured independent variable that is ultimately dictating these two, and these are ultimately two dependent variables. I don't want to drag you into the world of regression, but just make sure you understand, just because there's relationships between things doesn't mean doesn't establish a causal relationship between them. And then we use this term of R squared. You've probably heard this referred to as the coefficient of determination. This provides us an estimate of just how well these two independent variables or dependent variables, depending upon what they are, how well they're related. So in this particular case, the R square is 0.993. The way that that's often described is that with each change in X, I'm able to predict, or not predict, but I'm able to explain 99% of the variability that's occurring in Y. All right, that's how you've probably heard that stated in the past. Really quickly on the math, because I'm going to be using what we call residual analysis. Every time these individual points, so I identify what this model looks like, and this region represents this linear mathematical model. So it's linear, so it's as X increases by one amount, it multiply that one increment by 10, subtract 0.14, and then you're going to get what the Y value will be, at least for the model. What I'm interested in is what the deviation is of these individual observations from the model. Okay, so what's the distance between this little green point and the line that's represented by that, or the regression line that's represented by that dotted line. Okay, so I could actually show you the math of how you could do this. I'm not going to bore you with that today, but what I'm going to be doing is what we call residual analysis. I'm going to be looking at how the individual observations of yield over time differ from the trend, and just sharing what does that look like, how well have we been performing to the trend here more recently, and then realize there's different ways that we do trend analysis. So I'm going to be using a single year running average. It's not even just a single year average to adjust my model. There's a lot of different ways that we can do this. We can do a 2-year running average. We can do a 5-year running average. We can do a 10-year running average. They don't dramatically change the nature of the relationship of the data set that I'm showing you all that much. So I'm just going to stick with the average annual model adjustment. That may not mean much, but to the statisticians in the audience, that might ultimately mean something. So let's just dive right in. So this is corn yields from 1970 to 2019. To be honest, I could pick an earlier date with regard to when I start this type of analysis. You could argue maybe I should start at 1950. We could actually look at some watershed moments in agricultural history and say, okay, this is when we had double cross hybrids. This is when we started moving to single cross hybrids. This was the introduction of anhydrous ammonia. We could look at sort of those watershed moments to sort of pick out, okay, this is really when we should start looking at this analysis. I picked 1970 because I'm a Gen Xer, and my point of reference is 1974. That's when I entered this earth. Anything that predates 1974 didn't exist. That's obviously a joke. It did. I picked 1970 primarily because of some of the other data that I'm going to be showing you. I do have some limitations in data that's ultimately available to us or to me. I'm not saying the data doesn't exist, but I haven't found it. And so I sort of picked 1970 because I have some data that goes back to 1975, and that's just where I start drawing my trend lines. Again, you can make an argument for starting this analysis from different eras. You will likely get different trends. You will likely get a different regression line. The equation will look a little bit different, but this is a pretty good approximation of most likely what it's going to look like if I go back to 1950. If I start going pre-1950, pre-1940, a linear line really doesn't work all that well. You start moving into more of a quadratic with a plateau at the beginning, which we can model. We can do all of that. But for the sake of this conversation, I'm just going to use 1970 to 2019 as my model. So the question is, so this graph would indicate a 1.77 bushel per year increase in corn. Actually not quite. That's the multiplier in the equation. So this 1.84 would be multiplied by year, but then I have to subtract out this intercept. So it doesn't quite work out to 1.77 bushels per acre per year. Actually, I didn't do that math. I could, if you give me a little bit of time at the end, maybe I could run through that pretty quickly and just show you. Actually, if you wanted to do it your own, you could do this as well. Just take like 1970, or just take 1.87. Actually, that still wouldn't work. If you did 1970 and then put in 19, so run this math equation with 1970, get your answer, run the math equation with 1971, and then you'll be able to come up with what your ultimate average annual per bushel per year increase would be. Again, if you gave me some time at the end, I could probably run through that. But here's what I want to do. So if you look at this regression line and you see this R square, there's a reason I introduced R square at the beginning, is that's doing a pretty good job of describing to me that, you know what, this change in year captures about 86% explains 86% of the variability in yield that I see over time. Now, again, is time itself the driving factor for increases in yield? No, we recognize, and that was why I made that statement earlier, just because two things are correlated doesn't mean there's a causal relationship. And for some reason, I'm getting a fax. I never get faxes. I thought faxes were dead. So I apologize for the noise in the background. Pretty good job, but you do notice there is some deviation of each of those individual observations of annual or average corn yield every year from that trend line. And you know what, there's some years where it's above, and then we'll come up with a year that it's below. It's really interesting. It's not so evident on the corn, but on the soybean, you're going to sort of identify some trends. I don't know that I have a really good explanation for those trends, but we'll sort of be bumping along pretty good, and then we'll fall, and then we'll bump along pretty good, and then we'll fall. You don't necessarily see that with this corn data set. It seems like it's a little bit more random, not quite as systematic. But all I really want to spend some time on is talking about this concept of sum of residuals. So essentially what we do is we look at the difference between this observation and the trend line. And then all I'm going to do is I'm going to start clustering years. So from 2003, which is somewhere in here, I'm not really sure which one of these dots represents 2003. I'm going to suspect it's this one. From 2003 to 2010, the sum of my residuals, which is, again, I'm just summing the difference between the actual yield, the observed yield, average yield, and what the model would predicted the yield to have been. We were 38 bushels per acre over that 7-year period above the trend line. That means that was 7 really good years of corn production across the US. 2004, oddly enough, if you look at where a lot of our yield gains have occurred, they've really occurred in this millennium. So 2004 to 2011. So if I start here, but now I'm including this one that's below the line a little bit further, my average or my total sum was I'm 35 bushels per acre above the trend line over that 7-year period. 2013 to 2019, that's the one that we're currently in. If we fall where the USDA expects our yields to fall, we'll just be slightly above the trend line for this relationship. So if 2020 comes in where they're suspecting, we'll be just above, and it'll be interesting to see how that affects what the residual analysis looks like. The sum of the residuals over this 7-year period, again, 2012 was the drought. These 7 points were 31 bushels per acre above the trend line over those 7 years. So that means we are harvesting more corn than what our traditional trend line would imply. Now, the question becomes, and I don't have a very good answer for this, but this is a logical question that you might be asking is, will this ever turn quadratic? I'm not optimistic that it will. I'm not a very good prognosticator. I'm not very good at predicting things in the future, because I predicted way back in 2006 or 2007 that we would never see gas prices below $1.50 ever again. And then I was proven wrong somewhere around 2009, 2010. So I've really sort of backed off on making broad predictions, because invariably I fail at them. Will we see quadratic improvement? Not unless, only if something changes dramatically. We're sort of going to be plodding along this linear trajectory unless something changes dramatically, whether it's environmental, climatological, genetic. In order for quadratic change to occur, there's got to be pretty something dramatic occur that would influence and cause that. So while the corn yield trends are pretty impressive, right? Specifically in this millennium, we've been producing above the trend line pretty impressively since 2003 and up until today, with 2012 being that exception. The other part of this analysis that's really cool, because it starts to integrate not only productivity level on a per field basis measured in bushels per acre, but we also start looking at what does corn production look like when I start integrating what the average yield is, and then how many acres of production are actually growing corn. That gets even more impressive. So from 1976, and this is really where 2013, 2019 really starts to stand out, because if you think about it, what's the easiest way to increase our average corn yield in the United States? And the simple answer would be, well, focus all of the acres that are going to be growing corn to the regions that are most adept at doing it. So that would be Illinois, Iowa, southern Minnesota, a little bit of southern Wisconsin, northern Missouri, western Indiana. If you look at where our highest average yields come from in the state, now you notice I said the term highest average. I'm not saying that a farmer in North Dakota can't grow 250 bushel corn. That can occur, but on average, our best growing region is right what we call the traditional corn belt. If we limited all of the acres of corn production to be right there, our average yields would increase dramatically, but our total level of productivity would come down because there just wouldn't be enough acres in production. So this is really integrating yield and acres in production to come up with this total concept of bushels of corn produced across the United States. So 1976 to 82 is our all-time high as far as deviation. Again, some of the residuals above the trend line. That's going to be right about here and ending somewhere right around here. So 76 to 82, we were 7 billion bushels above what the trend line was. Now, again, the trend line is influenced by newer observations over time. So this trend line is always changing. Now, again, the good news is it doesn't change all that dramatically from one year to the next. 1977 and 1983 is the second highest at 5.9. I know these numbers are the same, but this one's slightly higher than 2013 to 2019. So from 2013 to 2019, we're almost 6 billion bushels above what the trend line would be. The really impressive thing for us right now is at least from the commodity price perspective, is the yields that we've achieved this year. And they're not going to be record yields. I don't anticipate that's going to occur. We're going to be just above the trend line. But we still have some pretty strong commodity prices out there in the ag market. That bodes well for 2021, and hopefully those markets will retain that strength, and China will continue to be a good importer of corn and soybeans, and Brazil, strangely enough, Brazil is actually taking some soybeans from us. I know that's hard to believe, but hopefully there'll be a strong export market and a strong domestic consumption for the products that we manufacture here, or the products that we grow here on the agricultural side. So from 1970 to 2019, 6 billion bushel above what the trend line was. Just to illustrate some of these, and for those of you who live in these states, you recognize this. Maybe for someone in Ohio that doesn't have a lot of knowledge of what goes on in North Dakota, South Dakota, some of these areas that haven't traditionally had a large amount of acres of corn. Iowa's stayed pretty consistent. Indiana's pretty consistent. Illinois, believe it or not, Illinois has actually grown 3 million acres since 1970. Kansas has increased dramatically. Not all of that is irrigated. I know that might be your first thought. There's a fair amount of irrigation out in western Kansas, but some of this is just improved genetics of our traditional corn hybrids that are better able to withstand some of those droughtier conditions that they experience out there in the Central Plains. Minnesota's had almost a 3 million acre increase. Missouri's pretty flat. Nebraska, again, considerably higher acreage of corn. Again, a lot of that is irrigated, but there are some areas where it's not, and they're still growing a lot of corn. North Dakota really didn't grow much corn in 1970. Now they're 3 million acres. Ohio's flat to down. South Dakota's increased. Wisconsin's increased. So we've seen this increase in acres in a lot of these states. And what's really impressive as well is when you look at the yields for some of these areas. So you think about North Dakota and South Dakota specifically, you think about the relative maturity rating of the corn hybrids that they're planting out in that Western environment. And it's pretty impressive what we can do with a 90-day corn hybrid with regard to achievable yield. I'm not saying that everybody's out there planting 90-day corn, but for that particular region, that I suspect that's pretty close to what their typical relative maturity rating is going to be. And you're growing 131 bushels in a fairly dry environment out west. That's pretty impressive. A lot of that is driven by genetics. A lot of it's also driven by agronomic practice. The way we manage the crops that we're growing is, I'm not going to say it's dramatically different, but it is different than what we've done in the past. And some of that's borne out with the improvement in genetics, right? A lot of this is driven by higher seeding rates, especially in the heart of the Corn Belt. But the reason we're able to plant those higher populations is because of the better genetics. They're better able to withstand some of the stress that they previously didn't have the capacity or capability to withstand. So it's really an integration of genetics and agronomic practice that results in the impressive yields that we see today. So soybeans is even more impressive as corn has been, at least more recently. As impressive as corn has been, soybeans is even more of a dramatic story. When you look at our general increase in the trend, soybean doesn't look as impressive as corn for a lot of different reasons. Soybean's a little bit more of a difficult beast to manage and really exploit the genetic yield potential that is inherent in that crop. But if you look at 2019, our sum of residuals above the trend line, we're 13 bushels what the trend line would be. That's pretty impressive when you consider the next closest would have been 2012 to 2018, and it was only 9 bushels per acre above the trend line over a 7-year period. And you got to go back to 92 to 99 to get to that 6 bushels per acre. So the yield gains that we've been able to make really since 2010 have been pretty impressive when you compare them to the long-term averages. And again, you notice I said there was systematic observations, like 3 good years and then you're down, 3 good years and you're down, only 2 good years and then you're down. That's sort of intriguing why you see that kind of a pattern. I don't have a great explanation for that, but it's just something when you look at data, the human eye is pretty good at identifying patterns. And that was one that really stood out to me when I start looking in this data. It's like, why does that go up and then it comes down pretty quickly? Again, I don't have a great explanation for it. If anybody wants to proffer one, please throw it in the chat, and I'll make sure you get due credit. Of course, it's anonymous. I don't know who submitted. Oh, I do know who submitted those questions, but nobody else could see them. So that's 2000. Or that's the soybean yield story. Then you start looking at bushels or total bushels or soybean production. It's even more impressive. Especially this 2019 sort of drug us down on soybean yield. But if you look at, what would that be? That's 18, 17, 16, 15, 14, 14 to 18. Those are some pretty lofty values above the trend line. You get a few more observations like that, and you can start turning this a little bit more quadratic or using a polynomial type of a regression model to fit the data. Again, for ease of conversation today, we're going to stick with linear. 2013 to 2019, 2.8 billion bushels above what the trend line would have told us it should have been on average, what it should have been. 2012 to 2018, 2.7. You got to go all the way back to 1976 to 1983 to come up with something that's even closer to that. And that was 1.7 billion bushels per acre. So again, soybeans have seen a tremendous increase, not only in the yields that we're achieving, but the number of acres that are growing soybeans. And we're all familiar with this. If you spend any amount of time looking at USDA information, it seems like every year we come back with new estimates of where corn and bean acres are going to look like, and beans just keep catching up with corn. Boy, I can't remember exactly. Was there not a year where we actually soybeans were almost equivalent to corn? I live in the state of Ohio. We used to be a predominant corn state. We're now predominantly a bean state. So we have seen some switches in acres in some geographies to be a little bit more favorable to soybeans. And some of that's actually driven by our wheat that's also in our rotations and allows us to double crop some soybeans. So soybeans by state. So Iowa, you look back, 50 years ago, just under 6 million. Now they're over 9 million. Indiana's grown by 2 million. Illinois has now grown by 3 million. Kansas, 3 million. 3.5 million. Minnesota, 3 million. Missouri, everybody's experienced some level of increase in soybean acres in this geography. And again, what's impressive is not only have we brought more acres into production, but the yields that we're achieving, again, I'm using North Dakota, not picking on North Dakota, I'm really illustrating their ability to grow crops that they really didn't have the capacity to do. Again, I think a lot of it has been afforded to us by genetics. 32 bushel soybeans with a maturity group that's somewhere in the 0 to 1 range, maybe a 1+. But I mean, you're still able to achieve some pretty impressive yields on a number of acres that historically just wasn't really in soybean production. If I could actually show you when this transition occurred, North Dakota really started growing soybeans about a decade ago. That was when the increase really started. And what they've been able to achieve with regard to yields or productivity levels is impressive. You think about Nebraska, Illinois. Now a lot of our states are growing in the 50 bushel range for soybeans. Again, we all hear reports of, I think there's been some individual growers that have hit the 130 bushel. I think that might be the historical record, but even whole farms that are growing 75, 80 bushel soybeans. Our ability to exploit the genetic yield potential that exists in the varieties that we're planting today, we're doing a much better job of managing. Again, genetics goes a long way, but we also have to make sure that we're setting those genetics and providing them a good environment to exploit, or that sometimes comes out as a negative connotation, but to express as much of the inherent yield potential that they do hold. And we're able to do that. That's quite impressive. Now, what you also have to consider with these pretty dramatic deviations from what the trends look like with regard to productivity and yield. Now I'm going to switch, as opposed to yield, I'm going to be talking about productivity, because if I speak to this on a yield basis, it makes my analysis a lot more messy and a lot more painful for me. So I'm going to primarily be talking about production. So that's going to be yield multiplied by the acres currently in production. So as you can probably imagine, as you increase productivity level, your nutrient removals go up. So this is more recent information. I think the only one that may be a little bit dated in this would be Purdue and Ohio State. They actually just recently came out with this summer the updated tri-state recommendations. This is not reflective of those values. This one I think is, but the Purdue I think was still relying upon the older tri-state guide. It doesn't necessarily matter. Those values don't change all that dramatically, but just to give you a sense of how much potassium measured as potassium or K2O, how much is being removed, how much phosphorus is being removed as a function of yield. So, or productivity. So how many pounds of nutrient is being removed per bushel? And I'll show you another slide here in a moment that's going to show you the trend lines for those values. But just to give you a reference point, and all of these are coming from the various land-grant universities and their different publications dealing with nutrient recommendations. Soybean, very similar. Again, the only one I think that might be a little bit dated would be the Indiana. It's going to be close enough for this type of an analysis. But you have the potassium removal, you've got the phosphorus removal. If you ever wanted to know how those values compare, here they are. Surprisingly enough, I'm going to go back to the corn slide here. They're not all that dramatically different. There is a range. That doesn't surprise us. Even like this value that's reported from Minnesota, there's going to be a range about that. There's actually one state, I want to say it was Illinois, and the folks at Illinois can condemn me if I'm wrong. I think they were actually starting to report ranges of potassium and phosphorus removal, which again, statistically makes sense. We're just simply representing the average of that population with these values. There's going to be some deviation. Some of it's going to be driven by genetics. Some of it's going to be driven by geographic location. Genetics, we suspect, is the bigger driver. But for the point of this conversation, a lot of these states have some pretty good agreement with regard to what the nutrient removal values are for corn and soybeans. When you're thinking about how many pounds of nutrient are they removing when they're harvesting X number of bushels of corn or soybeans. Now, I've done this. I've gone in and used this data, these nutrient removal estimates, and then the individual information from the states. I'm not going to do this for all states. Obviously, I don't have enough time to cover that in this particular presentation, nor that I have enough time to do all of that in preparation for this conversation. I just wanted to pull out a handful of states and talk about the trends that we do observe. And a lot of these are going to be driven by yield, right? Because the nutrient removal is going to be considered a constant. I'm just using the values that I'm reporting here, and then multiplying those by the total production, which is going to be, again, yield and acres under production, and coming up with this estimate of what phosphorus removal looks like. So we've got Illinois here in the green dots. I've got Indiana in this lighter blue. I've got this purplish color, which is going to be Iowa. And if you can't differentiate the two, just realize that Iowa does have a higher average corn yield and a higher total number of acres in production than North Dakota, if you can't distinguish those two colors. So it's pretty easy to pick out that this is Iowa. We've got Minnesota, and then we've got North Dakota. And the one thing I just want to illustrate is a lot of these states, and almost all the states that I've done the analysis on, we've increased nutrient removal by 2x. So we have gone from just under 200,000 tons of phosphorus being removed to now we're up to 450,000 tons of phosphorus being removed. So yeah, the question is, when you say when you say removal, are you saying taken off the field, or are you including uptake? This is just removal. Uptake is a different value. For the sake of this conversation, I'm only talking about removal. I'm not talking about uptake. So whatever the crop uptake, so let's just pick phosphorus as an example. 200 bushel corn, you're going to be taking up somewhere around 100 pounds of, actually just south of that, just below 100 pounds of actual P2O5 per acre. About 75 to 80% of the phosphorus that's taken up by that crop is going to be shuttled to the grain and ultimately harvested and removed. I'm only dealing with the fraction that's put into the grain and harvested. Everything else that is recycled back into that soil system, I'm not considering in this removal estimate. This is just straight removal, not uptake. Good question. Even in these states that you don't see as impressive of yield gains, we're still doubling the amount of nutrients. Actually, in this case, we're quadrupling the amount of nutrients ultimately being removed. So what does this mean for us as agronomists and managers of ground to make sure that we're supplying enough nutrient? A couple of different things, and I'll show you some of the trends on fertilizer utilization here in a moment. But as a result of this, there's going to have to be some amount of nutrient put back in that system to maintain soil test, to maintain profitability, to maintain production. Again, I mentioned the other big caveat in that statement. It's not just, oh, we've had higher phosphorus removal, everybody should be using double the amount of fertilizer than they did 50 years ago. That's not a true statement, because there's a couple of things that we have to consider. Is number one, what were the application rates 50 years ago? And I will show you that, I suspect, here in a moment. But just realize in all likelihood in the 70s and specifically the early 80s, through that time period, we were probably oversupplying both phosphorus and potassium. Now that has changed as we move forward in time. And as I often joke, as those nutrients have become less free over time, there is a cost incurred by supplying nutrients or supplementing nutrients into our crop production system. Those are not free. And there's not a whole lot of economic incentive to dramatically oversupply today, like there probably was 40 to 50 years ago. So that's the corn phosphorus removal story. Corn potassium looks very similar. I'm going to start going through these relatively quickly because we are starting to run a little bit short of time. Then we have soybean phosphorus removal. Again, what you would expect with the yields that we're achieving and the acres of crops that we are planting today. I'm only focusing, I continue to focus on these 5 states. Just realize that the other ones are really very, very similar with regard to the trends. There's going to be some subtle deviations, but they're all showing basically the same story. Potassium removal, again, just as you would expect, higher yields, more acres in production, we're removing more nutrient. Now, what do we see when we start looking at application, nutrient application trends? Again, this is part of the reason I picked 1970. I don't have information that predates 1975, at least on a state basis, where I can look at nutrient application. But as you look at Illinois, and that's, dang it, I always forget to change a unit. That shouldn't be removal. That should actually be K2O. Actually, it should be phosphorus application. This is what happens when you start copying and pasting slides. You end up forgetting to change some of the units. This is phosphorus. We were supplying 500,000 pounds or 500,000 tons of phosphorus back in the late 70s or the mid 70s. And now we're down to about 300,000. You look at Iowa's pretty flat. Minnesota's increased. North Dakota has dramatically increased compared to where they were historically. Indiana has decreased. Again, part of the challenge of looking at this high scale data over such a large geographic expanse is I can't show you all the information with regard to soil test. I will show you soil test here in a moment. But as yields have gone up, don't automatically assume that, oh, higher yields, fertilization rates have to go up. That's not necessarily true. If these applications were occurring well in excess of what the crop ultimately needed, the good thing about phosphorus and potassium, specifically across a lot of Illinois, is whatever I'm supplying, I've oversupplied then, I'm sort of taking advantage of into the future, right? I can capitalize upon some of that phosphorus that I banked, right? If we think about this as a checking account, I can take advantage of some of what I've oversupplied here. Now, environmentally, this probably wasn't very good, but from an economic and agronomic production standpoint, I probably wasn't getting hurt too bad by this management practice. But today, I'm actually taking advantage of what I oversupplied in the past, or what, maybe not what I did, but what my predecessors were doing 40 and 50 years ago. But eventually, even this is going to have to change if our yields continue upon the trajectory that they're moving upon. And this gets into the concept of agricultural intensification, ecological intensification. How do we do a better job of managing nutrient input into our crop production system to continue to allow the genetics of the crops that we're planting to express those higher levels of productivity, while also being mindful of environmental concerns with regard to over application or nutrient transport off the farm that can cause issues in water bodies. We have unique challenges today that we didn't have 40 and 50 years ago. And again, I apologize. I completely screwed up all of these. Those should all be, oh, so there's another question. Would manure application, yeah, don't confuse me with manure. That really, there's a word I won't use in a public forum. That sort of messes up my analysis. Now, there's a different type of analysis that one can do. That's actually not what I'm doing here. I'm just looking at broad trends. But if you go to the eKonomics website, there's actually a geographic tab where we actually do nutrient balances for each individual state. And in those balances, to your question, I have to account for manure application because that is a nutrient source that I have to account for. We have assumptions that allow us to do that. IP&I, who is no longer with us, they actually had what's called the NUGIS model. I think that's being maintained by TFI, the Fertilizer Institute. If you typed in NUGIS, N-U-G-I-S, they're following a similar approach. Now, the difference between the model that we have on eKonomics and the NUGIS model is reliant solely upon consensus data. So they're only done, or census data, they're only done every 5 years. Our data is actually using survey information, which is reported every year by USDA. So we have a higher frequency. And actually the NUGIS model changed to more of some of the more recent data. They actually went back and started looking at just the survey data, not necessarily just the census years. But there's a little bit of difference between those models, but they basically show the same types of movement patterns. So is manure an important consideration? Yes, but what's really interesting when you look at manure, and I'm only going to speak to Ohio because that's where I live and that's where I've done the most intensive analysis on this type of information, is the total number of animal units that we have in the state of Ohio have decreased actually pretty dramatically. And that surprises a lot of people. The other thing that's happened with manure is we've moved to more CAFOs, right? Everything is pretty well confined. Not every farmer has an animal operation. In fact, most of our row crop operators don't have much of a connection to animal agriculture other than the commodities that they produce are going to feed the animal side of our agricultural system. So is manure a consideration? Yes. In this particular analysis, I'm not paying attention to it. So great question. If you go to that economic site, I have to account for it in our annual model where we're doing nutrient balance. But for this, I'm not going to dive into it. It would be too deep and we'd waste way too much time. Not a waste of time, but it would expend a lot of time. So this is potassium. Again, you're seeing very similar trends with regard to application. We don't see the dramatic increases. If you think back to phosphorus specifically for places like North Dakota, and a lot of that has to do with shifting agricultural systems, right? Moving from a predominantly wheat intensive system to something now that's more diversified, that has corn, that has soybeans. And different yield levels that they can achieve, different nutrient removal values for those different cropping systems and those different crops that they're growing. Potassium has been fairly flat, pretty across a lot of the geographic expanse. I can certainly speak to that for Ohio as well. I didn't include that in this state analysis, but this is generally what you observe. Some states have seen some rather dramatic declines. Some are fairly flat. North Dakota is the only one that's on a slight uptick. The other thing you have to realize about the states that are more in the central plains, the nature of their soils is such that they're relatively rich in native potassium. So they don't have to actively supplement as much potassium nutrient as those of us that live further east. More highly weathered soils, a lot more rainfall, a lot more leaching of some of those bases, and potassium would be one of those. Again, I do apologize for messing up these Y axes. I will go back and correct them and at least make a PDF version of this available if you're interested. I can't make a PowerPoint available for this particular data set because some of this data isn't free, and I can't let that get out there because I do have to pay for it, and I don't want to be subject to a lawsuit. All I can really show you is the trends. So the other part of this picture is yields have gone up, fertilizer application rates, and a lot of our geographies have come down. That doesn't capture all of them. The other part of this is you start looking at what do the soil test distributions look like. So this is the IPNI 2015 soil test summary. TFI is going to be continuing this activity moving forward, which is great because it gives us a snapshot of what's going on in the respective states with regard to soil testing. Again, if you're interested, if you typed in IPNI 2015 soil test summary or typed in TFI 2015 soil test summary, you'll have full access to all of this data. We actually post a lot of this on our economic site, but do realize if you want access to the full suite of information, it's all available out there to you free of charge. All you have to do is sign up, and then you can actually get the real data, not just looking at the trends. You can actually get the data that populates these figures. And we've actually done some of that and do some additional analysis. I'm not going to be sharing that today. So this is the phosphorus sample distribution. If you're familiar with Illinois, I'm just focused on Illinois. I could do this for a lot of states. The critical level for phosphorus is somewhere around that 20 part per million. So if you actually do the math, and we do it for you on the economics site, so you don't have to go through there and try to figure out, okay, just what value is that? 39% of soils in the state of Illinois are at or below the critical level for phosphorus. 36% of them are at or below the critical level for potassium. Again, it's not that everybody's deficient. Everybody does need to be paying attention to what your soil test levels are doing as your achievable yield, or the yields you're actually achieving every year continue to move up. And that's the one message that you often find when you go to some educational content that we have on the site. And we provide some more granular guidance for specific geographies. We'll actually dive into, okay, if this is what your critical level, if this is what your soil test level is, and this is what I'm going to be showing you in the next slide. What sort of an economic payback should I be expecting if I'm going to fertilize using the land-grant university recommendations? And unfortunately, we don't have this for all of the states in the union. We continue to try to grow that information to provide you as useful of information as we possibly can, but giving you some general idea. Okay, if this is where my soil test level is, so if I'm in this 6 to 10 range, what might I expect with regard to economic payback if I fertilize that ground with phosphorus nutrient? The same would go for potassium. So it's, while I'm showing you these really high level, yields are gone up, fertilization rates have been flat, it's not as simple as saying, oh, then everybody should be dramatically increasing their fertilization or their nutrient application rates. That's not the point. It's, you just need to be paying really close attention to what's going on at the field level, because we notice these trends wide scale geographically that tell us, you know what, the amount of corn, the amount of soybeans you're taking off every field is increasing every year. Nutrient application rates are lagging behind. But the other part of that, the other very important part of that story is, what does your soil test levels look like? And that leads us to this is just an example of Minnesota. And really the only reason I sort of point this out is, if you look at Illinois, and I picked a really poor example to illustrate this, but I'm going to use Ohio as an example. You notice there's not a whole lot of fields that are above. Specifically, as you look at the 2015 analysis, less than 20% of the field at 50 part per million Braykerts P soil test level. What's really intriguing is, if you go to a different state, say Ohio, where we do have a number of animal units in production, you can see we have a number of fields well above 50 part per million. Maybe we're closer to 40% of our fields. And typically, to the question that was asked earlier, that's typically reflective of a lot of manure that's being utilized in our nutrient budgets. That represents part of the challenge of using manure. I never speak ill of manure. It's another nutrient source that should be managed just like any other nutrient source, but it does represent some challenges because of its nature. Using that to satisfy, let's say, nitrogen demand for corn, I'm going to dramatically oversupply phosphorus, specifically if I do it for multiple years. And that's how you get into a situation where you have really, really high soil test phosphorus levels, and it creates an environmental issue. And again, I'm not bad mouthing people who are in animal agriculture. It's just the reality of the situation. Minnesota, very similar, a little bit higher percentages of soil tests that are testing below. For some reason, my computer's freezing. I hope everybody can still hear me. They're actually trending down. So if you recall, one of the states that had the increasing application rates of phosphorus was Minnesota. So no surprise that the percentage of soils that are testing below the critical level for phosphorus is actually coming down over time. That doesn't surprise us. That matches the trend. And as a scientist, this is the kind of information that I look at. I look at multiple sources of information to help me craft a perspective of what ultimately is going on. I can never rely upon one simple observation and say, oh, this represents all reality for all individuals across all the states in the US. That's just not the reality of the situation. So that brings us just mean for you as if you're a retail agronomist servicing a customer, you're an independent crop consultant, again, servicing a customer, or you're a farmer that you're just interested in, okay, what sort of payback should I be expecting based upon all this information that you've just shared? What tools exist? And I'm not saying these are the only tools. These are the tools that we make available on our site that allow you to go in and actually calculate based upon whatever nutrient you're interested in. All tools to date are primarily focused on phosphorus and potassium. We don't have all states represented. We don't have all crops represented. As I often tell people, the only limitation to our ability to put information on the site is the availability of the information to build the agronomic response models. And again, I'm not going to throw my academic brethren under the bus, maybe a little bit, because I'm a recovering academic myself. They just have to make that information available to the public. And as that information becomes available, we can take that, convert it into an economic model, and post it on the site. And that's exactly what we've done with the models that we have there currently. We've got a number of different crops that are represented. It allows you, the user, to get a little bit more specific to your operation and your state. Again, I'm not going to say that this is the other challenge that, as it relates to even making a nutrient recommendation across, like my previous role, across the state of Ohio. Am I 100% convinced that whatever my recommendation is going to be perfect for all growers in the state of Ohio? I'm I'm a little more jaded than that. And it's not just a fact of being jaded. I have enough data in hand to tell me that it's not going to be perfect for everybody. If you really look at the way these recommendation approaches are devised specifically by the land grant universities and even the provincial universities and the provincial governments in Canada, they're really designed to minimize the risk of experiencing a yield loss due to inadequate nutrient supply. That's really sort of the way we bias these. Now, don't misunderstand and say, oh, well, so what you're telling me, if I'm above the critical level, there's no chance that I'm going to incur a yield loss due to inadequate nutrient availability. No, because there's at least some level of likelihood that that can occur. It's just that likelihood is very small. That's what's reflected in the ROI calculator that we do host on the site. And I would encourage everyone to take a little bit of time and go run through those models and just look at what the average increase would be. You get to select information. You primarily get to select the crop, the nutrient, where you're located, because that dictates what the model is, what your average soil test level is, and then some economic assumptions, and then what nutrient source you're utilizing. And we're going to take what the agronomic response models are that are published for those respective states or provinces, because we do have Canadian representation in here as well. And that's what is plugged into an economic model to provide you the feedback. The other tool that's out there is the nutrient removal calculator. Again, I'm not saying we're the only one that hosts this. There are a number of individual or entities that have these. Ours is pretty expansive. Again, I don't want to go so far as to say we have the most expansive nutrient removal calculator. We cover a lot of crops that you're not likely to run into. Specifically, if you're in the Midwest, you're never going to run into almonds. You'd be hard pressed to run into asparagus. You're not going to run into pineapple, but we have all those crops represented on the nutrient removal calculator. And again, all we're doing is we're taking information from publications with regard to nutrient removal. We haven't moved to the point where we're trying to make it state specific. As I illustrated earlier, they're all in pretty close agreement. So we end up working with averages with the realization it's not going to capture anybody perfectly. Well, it will, but it's not going to capture everyone perfectly. But at least it gives you a starting point or a basis for saying, okay, if this is what my measured yield was, how much in the way of actual phosphorus and potassium did I remove? Is that something I should be considerate of when I'm making a recommendation? Also thinking about what my potential ROI is based upon my soil test level. So as yields continue to rise, so too does nutrient removal. I don't think that's not a ground shaking conclusion to make. You all are probably intimately aware of that reality. The one thing that I continue to say is pay attention to your soil test levels. So we didn't speak at length about this, but this is something that I often talk about when I talk about soil testing. And the question always comes up, what frequency should I be practicing when I'm collecting soil samples or collecting soil tests? Should I do that every year? Should I do that every 2 years? Should I do it every 3? Should I do it every 4? I don't know that there's a great answer. I have sort of migrated to an annual analysis or a biennial analysis every 1 or 2 years. And here's the reason I say it is the more I have worked with soil testing and understanding what that soil test translates into, and even some of the uncertainty that surrounds that value, and that's a whole other conversation, by the way, that I do provide, but we're not going to have time in the next 7 minutes to digest it. Is if I'm capturing soil test information 1 every 2 years, I can see what my trends look like. I'm more interested in the longer term trends than I am a single observation. Now, and I can only hear people that are in the audience that are saying, well, that's great, but if I'm a farmer and I'm on a short-term lease agreement or my tenure agreement is not fairly long-term, it's hard pressed for me to do annual soil tests. It's hard for me to justify that cost. I get that, right? And in that situation, you're sort of reliant upon less frequent soil tests to help guide your decisions. But ideally, if I can track what my soil test level does over time, I have a much better picture of how my management needs to change to address things that I'm not keeping up with. So I've sort of taken a little bit of a shift in what I've traditionally recommended with regard to frequency of soil test. I used to be that every 3 to 4 years is probably good enough. So you know what? I probably want it every year to every 2 years. And it's not necessarily to dramatically change my inputs. It's just to monitor how things are changing across my landscape. And again, part of the goal or the ultimate goal that we're trying to achieve as agronomists is to identify all of the yield limiting factors and remove them. Keep evaluating different tools. Pay attention to the economic site. We're updating frequently with newer information, new publications, what's out there, what's being promoted. Just more of raising an awareness. We often are taking information that's published by land grants or even published in peer-reviewed journals, and digesting that information, putting it into a format that hopefully and capture some information from. Any tool that you can identify to make you a better agronomist, to make you a better, not just a recommender of nutrients. Obviously, all we focus on the economic site, it's not exclusive, but almost everything we focus on is on nutrients. We do deviate from that from time to time. Anything that makes you better at identifying those yield limiting factors and removing them for your customers is going to be to your benefit. It's going to make you a better agronomist. I appreciate the time. Thank you for the interaction. For those who did have questions, I'm going to give you another minute to ask your questions. And while I'm doing that, I'm going to cancel the share.